Hello everyone, welcome back to my YouTube channel Study with Tej. Today we shall know about cyclic codes and cyclic redundancy check. So what is cyclic code? These are a special linear codes with a special property. What it is? That is, if any valid code word is rotated, then it will result in another code word. If the example, if you can see here, if 1011 000 is shifted, that is, all these are shifted towards the left, and this one will go back and it will come here. If you can see here, the result is this 0 is shifted to 1 and this 1 is shifted here, this one here. Likewise, once this 0 is shifted here, this 1 will come back here. That is how it has happened. So the same thing, it is being represented in this equation, wherein a naught is copied to b1, a1 is copied to b2. Likewise, here a6 is copied to b0. Likewise, so this equation actually gives the rotation, nothing else. It's very easy. Next, knowing what is cyclic redundancy check. This is basically a method for error detection. If there is any accidental changes or error that has been induced in the communication channel, to detect them, we use CRC, that is cyclic redundancy check. CRCC stands for cyclic, that it means it is using the cyclic codes. Then R stands for redundancy. As I had said in previous videos, this adding redundant bits itself, we can identify the errors. That is the main actual logic behind it. So adding the redundancy, so R stands for redundancy. C is checking, that is data verification is done at the receiver end, whether the data is being corrected or not. So that verification shall happen. So it is called a CRC, cyclic redundancy check. Here they have given certain data word and the code word. How we have got this? Just remember this. We have just taken this example 1001, which ended up with code word 1001110. I'll let you know how it happens. See, if you see encoder and decoder at what happens at the CRC, here data word is of 4 bits. I had said that in the previous example. Okay, that data word is taken. Initially it has been augmented with n minus, that is here 4 bits are there, minus 1, that is 3 bits, 3 zeros has been augmented or appended with that. Then this whole thing is given to the generator. Here something happens. What shall happen, I'll let you know. That after that process, it will be giving some redundant bits. Okay, these redundant bits are again augmented or appended with the data word, and this whole thing is passed as a code word to the receiver. Once it has been received at the receiver, the code word is whatever is received, it is given to the checker. The same procedure what we applied here, that is also applied here, and whatever the output we get, that we check. This is called a syndrome. Okay, here this was redundant bits, or I call it as a remainder or a redundant bits. Here I call it as a syndrome, remainder or a syndrome. Wherein if the syndrome is 0, then the data is uncorrupted. If the syndrome is a positive or some value, then we call it was the data word or the code word received is corrupted. If it is 0, uncorrupted. If it is some value, then it is corrupted. So if it is corrupted, the whole code word is discarded. If it is uncorrupted, we will take out the redundant bits and only pass the data word. So data word is being extracted. What actually, I said some process will happen. What actually will happen? What is that process? This is the divisor which both sender and receiver has agreed upon, and this is the data word we had. As I said initially, we are just appending that with zeros, and now division shall take place for this whole dividend. We have to always check with the leftmost bit. If it is 1, then we can say 1 times the divisor. So 1 times the divisor, you write the divisor as it is, and you apply XOR operation. XOR operation is if both the inputs are same, then it is 0. If the both inputs vary, then it is 1. So if both the inputs are same, it is 0. If it varies, it ones. Same, 0. Same, 0. We ignore this part, and next we pull out this 0, and this 4 bit shall be taken for division. Again we'll see the leftmost bit. If it is 0, then 0 times. So 0 times of divisor, anything d 0 times is all zeros, same XOR operation shall happen. This is the thing we get, this we ignore, and this we pull out, and same thing is applied to this 4 bits. Likewise, once you do everything, then you end up in some remainder. We are not worried about the quotient, instead we are only interested in the remainder, and this remainder is been appended with the data word, and this whole things becomes the code word. Then what happens at the receiver end? Receiver end will receive the code word. Here this it is received as it is, no error is there in this. The same thing is given, same division shall happen here, and at the end if the remainder is 0, we say syndrome is 0, and hence there is no error, data word is accepted. But whereas here, if you see, there is an error induced, there is some problem there. So instead of 1, it has received as 0. So there is an error. So once you apply the same division here, you end up with some positive syndrome. So yes, they say syndrome is present, so data is corrupted, and hence the whole data word has been discarded. So this is the main logic with CRC. Thanks for watching. Keep watching Study with Tez YouTube channel for any videos related to computer networks and data communication. Thank you.